All right, good morning. Happy Thursday, April 2nd. Today we're going to review exponents and logarithms. And tomorrow we'll do our SchoolNet quiz over exponents and logs. This will cover, expanding, condensing, writing logs as exponents, writing exponents as logs, and as well as solving some logarithmic equations. Now, we're going to write these exponential equations as logarithms. So we want to write this as log base something of some other number equals something else. We just got to figure out where do I put the 3, the b, and the 17. So what we're going to look at first is what's the base of my exponent, because that's going to end up being the base of my log. So log base 3, the exponent always goes out on the other side of the equal sign. So log base 3 of 17 is b. I always fill in the exponent and the base first, and then filling in the 17 is just a matter of seeing what's left over. So again, we've got log base something of something else equals the last thing here. So what's the base of my logarithm? Well, that's got to be the base of my exponent. So base of the exponent is 12, base of the log is 12. And the exponent out here always goes on the other side of the equal sign, which leaves me with just 13 left over. All right, I'm going to leave you guys with 3 and 4. I'll post the completed notes here later on the Google Classroom, so keep an eye out for those. And we're going to go to expanding. So we're going to expand, then we'll condense. So expanding each log, we're going to look for what operation is in here, as well as do I have any exponents. And I've got a couple of exponents to worry about. So first thing we'll do, let's change colors. First thing we'll do is we'll get rid of any exponents. So, we'll do our PEMDAS, our order of operations. So, there we go. Oh well. So we're going to do our, don't have any, can't really simplify this because 7 doesn't go into 8 to the 5th. So we'll leave that for later. And we'll do our exponents. So exponents, we know, go out front. So 4 times the natural log of 8 to the 5th over 7. And our last 2 steps here, we're going to start with, we did our parentheses, we did our exponents, multiplication, division. So we're going to look at what operation is going on in here. And since that's division, I'm going to write this as 2 logs. So 4 times the natural log of 8 to the 5th, 4 natural log of 7. But since I'm dividing, what operation is going to go in here? What operation is going to go with division? And that's going to end up being subtraction. So I'll subtract those 2 logs. And I've got one more step. I could simplify this one a little bit further because I've got this exponent in here. So let's do that. I'll put my answer over here. So when I've got an exponent, like we saw here, I can bring it out front and multiply. So I will bring this exponent out front, and I'll say 5 times 4 times the natural log of 8 minus 4 times the natural log of 7. And I'll simplify this part here. 5 times 4 is 20. So 20 times the natural log of 8 minus 4 times the natural log of 7. And let's look at number 2. I'm just going to rewrite this. This is a square root. So if I wanted to write natural log of c times a times b to some power, well, what fraction power is the square root? I can write that as the 1/2 power. And now this will just be, a similar setup. So I'm going to leave this alone. This is going to be its own thing. I'm not going to separate anything in there. But I'm multiplying here. So I want to expand this. Again, we're expanding these logarithms. So I'm going to expand this into 2 natural logs. So natural log of c and natural log of a times b to the 1/2 power. And since I'm multiplying here, since I'm multiplying these two things together, what operation goes with multiplication in here? Well, that's going to be multiplying and addition go together. So this part right here, this part's done. That's simplified as far as I can go. But this part is not. I can still simplify that a little bit further. So let's work on that one. So I'm just going to bring down the natural log of c plus, and let's see, what can I do here? Following my order of operations, I can't really simplify this in the parentheses because I don't know what a or b are, but I can do exponents. So again, we bring down the exponent. So 1/2 natural log of a times b and we can do one more step here. So what could I simplify in this part? What could I still simplify in here? Well, I've still got multiplication in my natural log. So if I make this pink, I'll still bring down the natural log of c. But since I've got multiplication, I can split that into 2 logs. 1/2 times the natural log of a, 1/2 times the natural log of b. And since I have multiplication in here, then just like we saw earlier, I'll add those 2 logs. So our final answer is the natural log of c plus 1/2 natural log a plus 1/2 natural log b. And number 3, again, just like in number 1, we've got this exponent to bring out front first, and later on we're going to have another exponent in here to bring out front. So I'm going to leave 3 and 4 for you guys just to keep this video short. Again, I'll post those final completed notes in the classroom later on. So we're going to condense each log now. All right, so let's look at, we're going to go the opposite direction. So we're going to start looking at these numbers out front. We'll always look for numbers out front first. anytime I've got numbers out front, like we saw in number 1, like we would see in number 3, the way that we get numbers out front is when we bring an exponent out front. So in here, in number 3, we could bring this exponent out front if we were expanding. But now we're going to do the opposite. Instead of bringing that exponent out front, we're going to take that number out front and put it back in as an exponent. All right, so let's rewrite this. I've got log of 5 squared minus log of 8 to the 5th. And now I've got subtraction, so I want to condense this into a single log. So a single log, and since I'm subtracting, what operation is going to go with subtraction in here? That's going to end up being division, and again what we do is we take left to right, 5 squared divided by 8 to the 5th. All right, let's do 6 together, and then I'll leave 7 and 8 for you. So we see numbers out front. We can bring that into the exponent. So log base 7 of 4 plus log base 7 of 17 to the 3rd. And now I've got to condense this into a single log. And since I have addition here, then I can take this and write it as a single log log base 7 of, and what operation is going to go with addition? What's going to go with addition? Well, I'm going to take log base 7 of 4, and addition goes with multiplication. So 4 times 17 to the 3rd. And if you wanted to simplify that, you could. You could write that as log base 7 of, 17 to the 3rd times 4 is 19,652. So you could write it either like this or like this. Either way is just fine. And again, I'll leave these last two for you guys, and I'll post the completed notes in just a minute. And we've got 2 more problem types. Let's skip these 4 for right now. Let's go to solving some logs, because these right here just require a calculator, so that's not too bad. We're going to solve each logarithm. So what you notice here is I've got 2 logs, so log equals log, where they have the same base of 10. So it's not there, you don't see it, it's just 10. So what I can do is I can say 5x equals 2x plus 9. And then I can solve for x. 3x is 9, and x is 3. And I'm going to skip down and do number 15, because this is a little bit different format. So I've got 2 logs, and they're equal to a number. So what we should probably do first is condense or simplify this side. So let's do that. I've got addition in the middle, same base for these logs. So I'll write this as a single log And since I'm adding, then I can just multiply the two parts there that are inside the logs. So x times 8, or 8 times x, equals 2. And now anytime you've got a logarithm equal to a number, I want you to write this as an exponential form. So what's the base of my exponent? Well, the base of my log is 10. Base of my exponent is 10. So 10 to what power? And this is where you've got to be able to go the opposite direction of what we did here in the beginning. So 10 to the second power equals 8x, or 100 equals 8x, or x equals, let's see, 12.5. So again, condense this side into a single log, and then set it as an exponential form problem. So you have to rewrite that in the middle, and then you can solve for x. So